So what was it? Yeah, so what did I do since last time? I did very little. I just did a small refactoring of the goal logic to avoid having to do the goal verification thing every time. It's not actually working still. Well, it works, but the thing is I don't really verify the ultimate goal. I end up not verifying anything. So maybe we should do that first. But generally speaking, now I just write proofj and a bunch of traverse. I have to add validating to a bunch of things. To add the validating thing. So how does that work? The idea this is going to be complicated if it continues, I'm sorry. The idea is, well, there's a couple of ideas, but it's all, well, it's not quite everything here. So, general idea is I have this valid type, which is the same as unit, except that the semigroup and monoid instances are strict. And that is very important because we are going to have things that are either valid or an error. And so we are going to combine them using the monoid instance by using fold map, which we do here in validate. Validate is basically NF data. Nikitsu Super Robot Anime. That sounds fantastic. Validate. So we're going to do. You're going to do like NF data. So it's validate is like a force, not force. It's it's NF something. I don't remember. So it takes a term and goes deep in it. But I'm using that particular version because I want to restrict the types that do this to types that basically are valid or some construction around valid. For now, it's valid or a list of valid. We'll see later if we need something else. We have this overlappable instance here that is a catch-all instance, which gives me a type error from time to time. So for instance, if I forget validating, no, not here, but that one, for instance. Here, I'm going to get type error, and it says, oh, the type theorem is not a type that can be validated, which is sort of better than some random, like, icon derived whatever, something. Then we have the small machinery here that says, oh, I can prove an A if you give me a goal, I can turn it into an A. And basically, it just gives me the theorem if there is no argument, but if there are more argument, it will try to validate these arguments. And so it's exactly the same logic that I used before. Now, but it's just like, I just add this validating. Usually it's just, if I go a bit further down, this one is special, but most of the time, a simple view pattern here makes thing that thing is validating. So by validating, I should check that function. Should show that function for a second. Validating takes a function from goal to theorem and transforms it into a function from goal to valid. That just checks the theorem with the logic that I had before with ensuring, and that is all. The point being that if I force the ultimate valid that I will have by validating the ultimate goal, I will get an error if there's something wrong. So to this fact, let's add a bug in one of these functions, a normal one, and fix this. So here, how do I do this? I need to return the wrong goal. How do I do It's actually hard to make an error. Anyway, oh, here I can just prove something else, like proof sub. Actually easy to make an error. Okay. After intro, I always return something wrong, but right here, it didn't break anything, which is suspicious. Okay. So, because we use intro quite a bit. Okay, so we remember intro is buggy. And a better word. Approve, I think, has a... No, it doesn't. I should add it, I guess. Well, one step at a time. Proof sub. So now, I think I have a to-do about that. Used in the context where there are goals that we... I think this is not true anymore. Oh, we have done this. So today is about separating concrete syntax from abstract syntax. Okay, so now I'm going to do a run program or something. That's not very far. I'm going to eval tag, apply tag, check program. So when I do check program, I want the theorem. And some of these don't check the goals, I guess. So introduction goals equals apply m tag, tag goals. Apply one, it uses apply. Let's go and see what apply does. Yeah, there was this to do here. So we'll have a goal. So here I can do proved theorem, ensuring theorem equals goal. Nothing. Now I should have an error. No. Really? Oops. So it would appear that maybe, just maybe, let me check something. Yeah? What happens if I do this? Yeah, whatever. Aha, I got an error. That's a start. Okay. I think my normalization logic is wrong then. Or I don't use intro, but yeah, I do. Maybe intro was the bad place to do this. Or maybe I don't use that version of intro. Oh, sorry, that's G. Where's the sub? What I wrote proof sub. Yeah, okay. Maybe if I definitely use that one somewhere. But it didn't break. Let's start small. Maybe catching something that I shouldn't. I should here we should do something else. We should, like, we finish a number of things with CC. let's start by putting an error here. View. Okay. If I put an error here, it breaks. I do have another goal. I don't. But what I can do is proved hips equals proved goal heaps equals nothing. I believe this stack trace won't help a lot. Heaps equals nothing. No, not nothing. Empty list. It's 2 equals nothing. I'm gonna miss something. Concal equals concal. And bound variables equals empty, whatever. I could have put it at the end. That makes no difference. Bound variables equals yada. And now it broke. So I think it doesn't work every time. It's fairly surprising. But at the very least, like, we know it breaks. So yeah, I was going to add some stack trace on proved, just to trace it, but it's not really clear. That would help. As he says, an error called by ensuring, called by validating at 482. So where is this? What? That's really not this. 482. Oh, that's the one? Oh, fantastic. Okay, so I get an error for that one, but not for the proof. The proof doesn't matter too much. So have that fails. The applicative instance on const m. Do I use an implicative instance on const m? Anyway, so it's probably not useful to give I'm not sure. So validating. Oh, I'm not sure I need this actually. Do I use it? I use it. I use it for goal iter term. I have no memory of why I wrote this. Let's put that question for a second. I'm going to go back to this. Welcome, by the way. Of course, I'm just in the preliminaries of today, just having fun with things. Oh yeah, I see what you mean. I have no idea. What is const m? It's if it's an applicative m, then const m is an applicative. Oh. So it's const of m of unit. Fair. Why did I ever write that? I don't know. It doesn't make a difference. But yeah, I guess it's the same as using valid somehow. Well, these ones are probably these are probably lazy, so not really. But I don't think it matters here. Maybe it does though. We'll see. In the time being, could I validating Haskell stack and entering has a call stack, and that's what I get. Yeah, there's really no way to make this more precise. It shouldn't happen. It's just a safety thing. And we can see that it's not perfectly safe. So now CC theorem. We can. That was G, right? I can just reverse this. Yeah. Okay. Oops. Nope. So intro colon to do investigate why calling prove sub instead of prove G doesn't appear to produce errors. There's probably something that manages to avoid an error somewhere. Maybe it's repeats, but that would be weird. Really shouldn't. Maybe yeah, that shouldn't. Anywho. It's okay, it's a small error. Another thing I noticed, so let's just comment this. Fix check goal, check theorem in apply. So we don't have to do this anymore. Another thing I noticed is that this theorem doesn't prove anymore, the div1 theorem. And the reason being that last time we added type checking of tactics, and this tactics need type checking. Maybe I had done that on purpose and just decided not to do it last time or forgot to do it last time. I don't remember, honestly. But as I prepared for tonight's stream, I noticed this. So it's easy enough. We have an extra goal that is here. No, that one. And that is not proved, and it's a very easy goal. So it's at the end of this. I don't know if it's the first or the second one, so let's have a look. It's interesting that it lets me just fails. It's funny. So it is the first goal, so we can just add a side condition here. And to add a side condition, you just add id, something id, and the something in that case is done. And that should be fine. Yes. Excellent. Fix div1 now has a complete proof with type checking. Well, whatever. I don't care much about the syntax. Oh, the spelling of type checking. I write it in many different ways depending on how I feel. Before I start, I want to add me a to-do, which I think I'm going to put here for the time being. So, to-do, make types more rigid. Here is the idea. Instead of systematically of a term of I type, R type, I type, yeah, intrinsic type, like being a value of of all the refinement of, I'm going to copy this, don't want to type it every time. It will only be a value of type sorry again. Yeah, instead of being a value, it will only be a value of types of the form and of type this p, and like you can like, and like subtypes of this as well. Okay. We can still coerce. It's still things with the same R type. So in particular, it is not like it's not necessarily an element of what am I supposed to write? N of type baby n, and n is like next 0 implies n, but we can still coerce is the point. To coerce, we must use an explicit coercion. Something like this. Read n seen as, etc. Element of, and this generates a proof obligation. It's going to be more consistent. It's also it's sort of the quotient problem. This way, an element is only has only one equality applying to it. And you need to coerce to get another equality. I think that I want seen as to be equality preserving, meaning it can't cast from a quotient type to a less quotient type. But maybe we need a variant that can go the other way. But I think it can cause problems, I'm not sure. It is the same intrinsic type. It is nat to nat. So yeah, the question. So what is the intrinsic type of thing of this, the underlying type of this? And this is nat to nat. So they have the same nat, but it is not. There's a couple of things to realize. It's not feasible to keep terms unable to speak about refinement types. You want to add type annotations and so on and so forth. As soon as you do that, then a term is not really reducible to a non-refined term, like with only an intrinsic type, together with some refinement information, metadata. It's not quite that. And if you do that, you might just as well bite the bullet and make this refined type just a tiny, teensy bit more rigid by saying, okay, we're not going to let you move an element to any other type that has the same underlying intrinsic type. We're going to let you do that implicitly in some circumstances. So in that case, it's other subtypes. It's a bit more generic than only subtypes that are equal. Somehow you can move to a bigger subtype quite easily. But it doesn't necessarily make sense. Like, for instance, the current typing algorithm, when it has an f of that type that I have underlined here or highlighted here, it will not accept an n that is not 0 and ask you, yeah, it does something that I just don't know what it is. And if it can't do that, it means that I'm already not considering all intrinsic type, like just all refinement of one type to just like be fluidly applied. I already have some rigidity, and this is just leveraging this rigidity or being consistent with this rigidity in order to make equality canonical. And that's sort of what I was looking for. It's probably going to be better. So you don't need a type annotation equality. Equality is just equality. And you can do congruence closure and so on and so forth. And if you want to convert between two refinements that are not implicitly coercible, you just need to have this explicit coercion. But this explicit coercion is part of the term syntax and can be used by automation as to transform something into a black box, for instance, or to read something as a surjection, if it's the simple one. I'm not exactly sure about that yet, but that's the general idea. And I think it's a good design. It's I was a bit anxious last time, if you remember. Yeah, it's just an example. It's any type. It's for all n to n, if you so will. All the types. But it's visible in arrow types because right now it's my only structured type. So it will very much apply to quotients and it will apply to every type constructor. The point is, you can only coerce between things that are basically of the form something sub with the same something. Bye, Ray. Have an excellent night. And talk to you soon. That's the general idea. This rigidity is, I think, key. I was very anxious 2 weeks ago about this quotient thing. You remember, James, you asked me about it, and I was like, yeah, I mean, if we're going to do that, probably, maybe, sometimes. And then so this sort of popped up during the week. And I think it's the right design. It's this sort of good middle ground where things are a bit flexible, but not too much. And I think it's the key to get just the good things about type theory and the good things about set theory. Yeah, same. Like when you coerce, basically, you will want to say, apart from the equality preserving thing, let's ignore that for a second. You just said, okay, if I coerce, the idea is that f or x coerce to t. I think I called them toe, so let's write it toe. Is well typed. Is well typed when the intrinsic type Okay, here I am again. I wanted to spare your ears from this. Intrinsic type of x is the underlying type of toe, and then you have the proof obligation that you know, like from splitting toe into a pair, I-type plus membership predicate. So there. So the explicit coercion, the CNAS coercion, is really like very free, except probably for equality, and maybe we'll have another one that doesn't respect equality but has weaker property. And I read it CNAS because it is meant to mimic to some degree the CNAS sentence in mathematics. I have this item and I see it as an item of another type, which is something we do all the time in maths, though generally you have like even wilder transformation than this, much wilder. It's a monoid seen as a category, but it's the same idea. So the coercion is not obvious, so you mention that you're coercing the type of something. That's the idea. So that's a to-do for soonish, because it will let me do quotients, and I will be very happy. It will also remove the non-canonicity inequality type checking. I don't have a syntax for quotient type, so it can make it up. And of course, we can have quotients defined inside data types, but that's a story from when I have data types. I don't know yet. I may steal your ideas for that if we manage to make something of it. Anywho, that were the preliminaries. Now back to the subject of the video, 40 minutes after starting. So my idea today was to break everything. So we have here a grammar giving me a concrete syntax for things. But this concrete syntax is not very nice to manipulate. So very soon I want to have for all types, for all being like part of the syntax of terms, and I need congruence closure to work on these, and something that might be very crude, but at least at the very least need equality to understand alpha equivalence. And for that to happen, I need probably De Bruyn's, and I'm gonna use De Bruyn for now, which is gonna be interesting because I have to code all the De Bruyn substitution logic, which when it's done was easy enough, but before it is an interesting feat. Well, it's just there's a lot of engineering, and I always get my head upside down about this. It's just anyway, so I'm going to like basically copy this static syntax, this concrete syntax into an abstract syntax. I will also add comments, and I will start adding some syntactic sugar in the syntax. And we need transformations both ways. So I'm going to start doing this for a little bit. So I'm going to split this. Now I'm going to split this one in two. What do you mean, Bath? I'm going to put refine here. I'm going to put in the big one. What do I do? Oh, damn it. Okay. Start over. Split. In the third one, we're going to put refined. in the first one, we're going to put main. So we're going to compile that because so there are two goals to recap. Goal number one is having alpha equivalence better understood. That matters. And goal number two is having syntactic sugar. The Bruyne substitutions, oh come on, I've done that like maybe 50 times. It's not that bad. It's just really, really hard to remember everything you need to do. At first. It's less intuitive. It's super easy with type de Bruyne's using something like what are you doing? Whoa, I'm lost. So in this repo, there's the unfixed binder thing. If you do something like this, writing substitution is super easy. Actually, this is substitution written generically for all things with de Bruyne's. But I don't think I'm going to use it just yet because it makes other things harder to type to play with. You have more types and you have to deal with them. Yeah, I'm probably going to do that later. I'll get around to it maybe if I think it's not too hard, but I don't want to be blocked on this today. So we're going to implement them manually. But we can use that as a guide. There's a shift and a lift, and I don't remember. We can think in these terms. What would it take if it was? This is a rather fun thing. It does generic substitution. It defines, so it defines the monad instance for the thing. It gives you a two-dimensional catamorphism. It is amusing, but it will be amusing another day. So let's write abstract syntax. And so it's very normal to separate things into abstract syntax and concrete syntax in real life. Also, you can count how many times I'm going to drink from this mug before I realize that I want to fill it again. It's empty right now. So I am not going to import LBNF, the refine module, unqualified anymore. I think there's nothing that I need to. Yeah. So that's what I'm going to start with this. Import. No, that's not the right one. The refined one, yeah, is the one. Import qualify, define as concrete. Boom. Except did I lock my, no, it's fine. So the funniest thing happened. I need to be a bit careful actually. My hard drive, which is an SSD, has corrupted sectors. That's not funny. But the funny thing is that the sectors are on my swap partition. So for that like week or so, yeah, I read the racket scope thingy, and so it doesn't really solve my problem for the abstract syntax. However, it's interesting, and it might give me an alternative to shadowing during tactics and so on and so forth. And that can be interesting. So I'm thinking about it, but I'm not going to deal with it today. So I was saying, yeah, when my computer swapped in the past couple of weeks, it would just crash, and I didn't really understand if it was a wiring issue until I realized that this was the swap partition. That's why it was random. And so I can't swap anymore. I have plenty of memory left, apparently. But I just, if my memory reaches 32 gigabytes used, my computer is going to crash and turn off, basically, poorly, unless it manages to kill an application first, which probably will be OBS, so the stream will crash, only the stream. But Linux doesn't have a good track record of managing. It doesn't really know how to reserve some memory for itself for the cleaning stuff, so it just gets overwhelmed, never gets a process, and something very often crashes, or something critical is terminated, something like this. Anyway, so we're going to define a term syntax, which is exactly the same as the other one, but we're still going to copy it. Equals net of integer socks of term var of ident app of term. Interesting. I didn't notice that. This was supposed to be my non-scope ident. It's okay. That's interesting. I'm guessing it's in language BNF, so I'm going to import it from there. I don't want it all, but I want ident for the time being. Actually, it's not an ident, but I will need both. So I'm lying. It doesn't. Okay. We're just going to import ident from there then. So yeah, the racket scope thingy. What? Oh yeah, now everything broke. I've started with this. No, that's not what I wanted. Shoot. Okay. You know what? I don't want to replace it this way. However, I need two vars. I need name vars and just var. Which is, let's say it's an int. Of course. Then I need inet. Everything is going to break. That is going to be fantastic. No, itype, sorry. Equals inet or iarrow of itype. This is going to be the funniest thing. Now, every time I add syntax, I have to add it in like a number of places. It's gonna be fantastic. But it's kind of unavoidable. Not sugar though. I can add sugar in the concrete syntax. And then I need transformations both way, one for parsing, one for printing. All normal stuff. And in the transformation in the other way, you can do some folding, but we're not going to do any today. Later, maybe. Inet, r sub, r sub takes an r type, an ident. So we're going to take the ident anyway, but the ident is a suggested name, but not part of the syntax. So it's going to be ignored by equality in particular. And this one, for the moment, we can derive equality. And this one too, but this one we can't. We're going to have to write equality manually. That gives me a syntax error. That's worse. R sub, I forgot something. R type and a preposition. I don't know. I'm fine with nats being built in. I don't know exactly. I mean, one of the good things about this presentation is we don't need to have everything in the form of a data constructor, like a data type that is a fixed point of something. You can just axiomatize things. So we can have nats and integers and maybe finite integers just being axiomatized. There will be some challenges like having to prove that things are indeed total, which I haven't come to solve yet. Oops. Prop is not defined yet, but that's fine. Data. Prop. Here we go. P true. P false. P equals. Term. P not of prop. P end of prop. Pimple. Still funny. Whatever. There's no P for all yet. I wrote derive instead of deriving. Of course I did. Yeah, so built-in. So one of the things I want to aim for with this is having actual built-in types, primitive types with just axiomatization. I don't know if you know, but one of my first research projects. So ident R type. Do I forget anything? Prop the ident. One of my first research work was around compiling like native bounded integers in Coq. Okay, I'm giving in. And so what we did for that was having a normal data type that represented faithfully but not efficiently bounded integers. It's pretty big data types. It had 31 bits for reasons that may not glue. That may not be best explained right here or right now. Maybe I will. Yeah, it's just decoration. It's not formally part of the syntax. No, because it's an integer. These are the Broyn things. And so I have this type that was a 31 tuple of booleans, basically, that represents native integers and the 31-bit integers. And the implementation of everything on it is absolutely terribly slow. But then we have the compiler that compiled to bytecode for Coq hooked into that and recognized this. Oh, that is something I know. Let me put an actual number there. That was fairly clever. It was fun. And it kind of works, but it lets. But the thing is, it has a bunch of problems. It doesn't let you use fixed points on natural numbers. Anyway, you need a sort of a fix or an iterator that is understood and that is that is implemented natively as well. And it's also very, very slow to type check. So there's an application of this, which is type checking SMT traces. And the problem is that SMT traces, they're basically a bunch of integers. And if you explode all of your integers as instead of one or a couple of bytes being a tuple of 31 booleans, each stored as a word, then you have this gigantic term, and you spend all your life type checking it, like much more than the computational part, which is ridiculous. That's why people are working on adding actual primitive integers to Coq as well, and it's a harder kind of work because Coq is not very fond of axiomatizing operations. Come again? Is plus partial. What plus? I don't need to copy tacx because that's a pure syntax thing. Do I need something else? No, I'm good. Oh, you mean on the 31-bit integers in Coq? No, it's total. It just wraps around. What did I do? Yeah. So I thought, yeah, there was you asked a question about the scope set thing. And one thing about the racket scope is that I can't convince myself is correct. It's clever. It's what it's really done to achieve is to be able to work with macro expansion that is it's not only a substitution, but it can have effects and put things in references and move things about and be able to, despite the references and the effects, have some proper scoping. I don't fully understand why it works. Like I get it, but I can't prove it that it's correct, which is funny. But it might give me a way to, because here you see, I've got, yes, a built-in z over 31z, and on top of this we can make big ints. The method for that had been worked out previously in 2003, 2004 by Benjamin Grégoire and Thierry Laurent, and so they already had a library for Coq that did that. That took a z over 2 to the nz and made a bigger one, or made an arbitrary z implementation, or n. However, it was a bit slow for reasons, and so it's only useful if you're grafting syntax from one place to another. Well, it might be useful for more than this, but the reason why they can't use De Bruyne in any way or something like this is that it's not only grafting. Grafting is fine. It's just like it's really the shuffling around because they really want to support things like I don't know, getting some things out of loops, etc. I'm not very good at code generation, but I remember a number of examples that use references, exceptions, try catches, etc. within macros to achieve efficient code generation. And I think that's sort of the reason why they absolutely need a system like this. Whereas I don't, but I might still find it useful. We need to define equality for these two things that have binders in them. Let's do it manually and see later if I can improve on it. So Arna It's really weird to write this. I don't know why. R sub to p equal r sub I can't. Oh, I see. I'm mixing on my keyboard key. Let's say sigma. It's close. It's better than epsilon, I guess. Q. So see, that's what I meant by it's not part of the syntax. It's ignored here. To L to R. Okay. I think if I go on, I can type Taurus. Yay! I could use zodiac signs as my variable names. That would be absolutely epic. I think we can use emojis as variable names nowadays if we use them correctly. I'm not sure actually. Probably. I can check. Oh, I think my emoji picker has been overwritten for something. Never mind. Sigma L sigma R equals 2L equals sigma L, and 2 are sufficient. 2R equal sigma R. Here we go. Interesting. Okay. So let's not write it this way. Maybe it doesn't work for method names. Ooh. I forgot that. Sigma and P equals Q. What? No. Interesting. I wrote things. Oh, that was the problem. Can I, yeah. Because there are errors, it doesn't even complain that this is incomplete, but the other one are false. I'm going to play the same game here. I'm going to oops. Interesting. Instance eq prop where true p false equal p false equals false p equals let's go t u equals p equals vw if t equals u v equals w. Interesting. P not q if p equals q. PQ equals. By the way, I'm explicitly not deriving generic for any of these. It would eventually succeed, but it would be a useless instance for me. It would not represent what the type is supposed to mean. That's for all these that have binders. That's the reason why a library like unfixed binders is useful, or variants of these. Better one, worse ones, doesn't matter, because they generate the boilerplate for you. And they can't make a mistake in things like this, which is very, very error prone. On the other hand, there's no real good solution today. I mean, I wrote unfixed binders, so I like it, but it's got plenty of issues. You have a lot of boilerplates to write anyway, because you have this fixed point things. Now it's not happy because when I infer things, I use the syntax, but to do that, I will need to, yeah, okay. So if I do concrete type, I will get something of the wrong type. Prog GG92. That's clever. Yeah, that is actually very clever. I like it. We can do even better than this. Let me get back to you on this. No. These are all concrete, pure concrete things, I think. Maybe I'll need equivalent. Oh yeah, so I figured out why there is not a support for maybe in LBNF, and that would be because LBNF is multi-backend, and it's not clear how to support optional things in other languages, like Java in particular. I'm gonna get there. Fantastic. That's because I wrote it wrong. Okay, so let's do something. It's clever, so let's do this. Let's get back to your idea. So data an a equals an a, not data, new type. Instance eq an a equals where, sorry, something equals string. Boom. Yes, so sucks doesn't take a term. It's just a function. And now, instead of putting these, we can do an annotation is an accidental part of the syntax used to give user feedback, but is really but doesn't affect semantics of the syntax tree it is used on. There's many spaces that come. Where do these spaces come from? This is weird. Okay. There might be a problem with my keyboard. There's almost certainly is a problem with my keyboard. Shit. No, it's not the right time for this. Let me try something. Now, this is not meant. This one still has some. Okay. I'm missing part of this, but let's try to. Sorry. It's not working. Might make the rest of the stream difficult. Can I? I'm going to look up if I can how I remove caps on this keyboard. I know gently. Oops. And try to open this. It's definitely the keyboard. I won't. I just need the user manual, which I mean I have somewhere. Oh. Whew. Yeah. Well, thing is, I don't happen to have a replacement keyboard for today. Well, I guess I might, but it's kind of damaged. I've changed it for a reason. pull hard. Straight up, and you should just be sure to pull straight up. There are some keycaps to pull over, but I don't have one of these. From the side with the fingers. I am going to lock my screen for a second. Actually, I can just unplug this. Let me just unplug this. Maybe. Oh, sorry, it's a RG45 cable. Maybe it's going to be unplugged. Okay. So here's the thing. I'm going to pull the key. It's kind of hard. I feel fat-fingered now. Maybe I should start with the control and remove. Okay. Oh, sorry about the noise. Forgot to mute again. So here are the keycaps if you want to see. I don't know if I'm showing them right. Let me pull the camera up so that I see. Here, so you can see that. That's the space keycap here. I'm going to see what it does. If, oh yeah, it's not plugged. I need to plug it again. Do some experiments without the keycap on. If the switch is damaged, I am in deep troubles because I don't have a replacement. The switch is not really. The mic seems to go haywire and say, "Oh God, don't do that noise again." Every time I the thing. I'm going to do it again then. It's not super clean, really. Well, let's try this again. Unplug. Unplugging is hard. It's really not in a convenient position. It's a regular RG45 cable between the two bits. I could just unplug power. It's easier. Let's do that. Okay, so I unplugged power. I can press things down again. Well, live troubleshooting, I guess. That's a first. You need a first for everything. Okay, so. I have no idea what happened, by the way. I didn't figure it out when I opened it. It seems to be fixed. I'm lucky to have my material with me. No, I'm not. I can't close my things. Okay. Sorry about all this. Well, that was some unexpected fun that we just had. Yes. I'm just checking that I didn't write random things that I didn't want to. Okay, I didn't. Okay. 2, 1. Okay, so you were right about this. So Anne is here again. Here we go. therefore it is considered that all annotations are equal. Which is a bit cheaty, I guess, but it's fine. And but that the other one was 2. And then we can just put an of ident here. We can put an of ident and deriving. No, this one is not an actually. This one is an actual ident. Deriving eq. Remove this. That was a great idea. Thanks, James. Interesting. Oh, I just forgot that one. The error was just pointing at the wrong place, but or it's the right place to have an error. It's not the one I wanted. No instance for eq. What did I do? This proper thing. Okay. Yes. It's actually surprisingly easy to do silly things while you're presenting. You've probably blackboard or whiteboarded before. Like when you're in the when you're close to the board and you're looking at the thing and someone points something, says there's something wrong, and you're like, where is it? And you have like your finger on it. It's like, well, just explain. I don't understand what you're talking about. Like it just happens so often. When you're doing a presentation like this, you're so I don't know, there's something that makes it so hard to like see what you're doing or understand. So now we're moving to the traversals, which of course, tunnel vision, I imagine so. I don't know why the type of these things changed. However, we want to change their type anyway, because we are not going under a collection of names anymore. We're just going under level. So we're going to replace all the collections of idents by just an integer, which is really a natural number. I think I was doing computer science. I had been doing computer science for like, I don't know, half a dozen years when I realized it was integer and not integer. So weird. I got used to it since. Now, of course, something really weird can matter. Oh, I see. Yeah, that's the reason. But we don't care about that. So it says, oh, but that's an add ident, and you asked me for an ident. No, I don't have one. But we really want to do like n+1. Here again. With int every time, and here it's n+1 or 1 plus n. That would be 0. Hello. It's not L percent. Is it control L percent? Works now. Hello. Things happening. Interesting. Yes. It doesn't work. Could match representation of type integer with int. Why did it decide to have an integer anywhere? Are type subs? Did I put integer myself? I'm not below this. Yeah, I did. Great. Oh yeah, because I was talking of pronunciation. GitHub gists, GitHub gists. I think I say gist most of the time. I guess it should be a gist. Huh. Do you pronounce maggot or maggot for the for the Git extension thing? For Emacs. You don't use Emacs, do you? The latter, maggot. Okay. Well, it's very ambiguous, isn't it, though? You do use Emacs. Yeah, okay, sorry. I don't remember most of the time who uses what. Again? Why does that happen? I think I pressed the wrong button. Yeah, it's magic. But on the other hand, it's all about Git. And the JIT is Git. So it's very ambiguous. I think it's on purpose. I strongly suspect the author to pronounce like half the time one and half the time the other, just to confuse people. But I really never met him, so I don't know. Okay, so now things are getting more interesting. Because we have to do the substitutions. And that is fun. So where are the substitutions? Free vars are not very useful anymore. Not even have the right type. So right now subst takes a single element. You really can't do this. With thinginess, stuff, yada, De Bruyne's. So you have a bunch of De Bruyne's and you will extend the substitution. It's very important. This is called shifting, I think. I'm pretty sure. You can lift and shift things. It means completely different things, though. They define one in terms of another, so it's not that different. The point being that when you have this term that you want to substitute for 0, and it passes it over a lambda, then suddenly it needs to substitute for 1. And so you need to have the substitution that say, oh, I'm substituting for 1. One thing, what you could do is say, oh, I've got this substitution that takes a number and does that, and then you sort of change the number locally. It's possible. It's not the natural thing to do. The natural thing to do is say, okay, a substitution is a list of terms that I'm going to substitute, like the first one for 0 and the second one for... We should have a word 0th. So much trouble will be spared if we realize that ordinals start at 0. But anyway, ranting. So the 0th one and the first one and so on and so forth, substitution. And then when you pass a lambda, then when you pass a lambda, then you add this thing where the 0th term is 0. However, by doing this, you also have all the free variables of the old terms. Like if the 0 passes a lambda, 0 to 0 passes a lambda, now it needs to become 1 to 1, so you need to lift every term in the substitution. So there's this sort of thing where you lift the term by substituting like particular substitution that can be seen as infinite, I guess. I haven't done that for years. I need to remember. I mean, it's very easy to do that with an infinite substitution, I guess. It's okay to do. And so you have this 3 things that are defined at the same time: lift, subst, and shift. It's possible to define lift. So lift is easier than subst because it's just acting on the terms, but you can do that as a substitution. If you go back to unfix, I think lifting is just you have a term of type A, and you want to make a term of type maybe A, so you just have to add just at every leaf. So it's a functor instance, whereas full-blown substitution is a monad instance, and that's kind of the difference. Yeah, well, that's the general idea. Here we could do the same, implement lift first as being some kind of a function, but it's easier to define all of these as recursive. So we're going to start with terms because that's where the recursion is, and then we're going to do the other substitution. So it's not going to be pretty. I'll put some order into this one day, TM. So what we need is function lift takes a term to a term. I think that's sufficient. A function shift takes a substitution, which is a list of term, to a list of term. And that's subterm. So shift, I don't know how to implement yet. Lift, I don't know how to implement yet. And I'm going to do subst. And subst is, oh yeah, subst is super easy because I don't actually use lift in subterm. So for now, soon I will lift and shift. But for now, what we're going to do is subterm takes a list of terms. So that's the substitution. And you add var. So we're going to call that I for index. And so data term, oops. Okay, so let's take this. If it was PHOAS, I would have something like this. Yeah, binder things are a bit of a bummer. And instead of being a prop, it would be a v2 prop. Something like that. It doesn't make sense right now. I'm going to erase it in a second. Okay. And so the idea is that this is your variable type. And in here you would have term, you have a version of term where instead of int here, which is a Broin, I would have a v, and that would be term v. And then whenever you want to do a recursion on these things, you have to give a special v that you will consume, and everything is generalized over v. So, for all v variables, yada yada, something something. And so to define equality, you take two of these things that have type like R type of something. For equality is probably integer, and then you would need a counter. And whenever you encounter one of these, you say, oh, it's foo of v of the next value of the counter, and then you can just derive equality recursively. One of the issues is that, of course, is that this is not syntax, and so it won't be lazy. You would recompile, recompute the term every time. It is not without its niceties. It's cool. It has some advantages, but I think that it won't be quite what I need. I reserve the right to change my mind later. But I think for now we're going to plow forward with the De Bruyne, which I think I seem to be able to remind how to do. We're going to lift colon. I'm going to call that lift term. We'll need many of these. So we have a substitution. So which one is it? Maybe int? No, I want maybe. It's not too hard. So you do. You'd say if I is smaller than length of subst, then we're going to traverse the subst twice, but we said that performance were not really our problem right now. So we're going to take the ith term of subst, starting with 0, and otherwise we just do the thing. Isn't that fantastic? Now, it's unhappy about this. What? Have different numbers of arguments. Yes, it is quite correct. Oops. Okay. I think yeah. So I don't know if binders are useful enough for the average program to deserve special treatment. And if they don't, and if there are non-binders things that are just as useful, this is sort of, I don't know what we're supposed to do to solve that issue. To sort of have a generic solution for this, but I guess it's part of this conversation we're having. So this is very easy. This is subst term of 1. We'll have to lift, well, we'll only have to lift terms, I guess, so that's fine. And shift takes a bunch of terms. You should need to shift by, by 1, I guess. We shift by 1. There are also like more compact presentation of these, but it's fine. If this is correct, it's going to be amazing. Shift is just 0. Var 0. I think I forgot to close a window. Give me a sec. I hadn't. I just saw there was a lot of insects around me that seemed to want to suck my blood. And I thought maybe they had entered by an open window with light attracting them in, but it doesn't appear to be the problem. So again, var0 here, followed by lift term, well, okay. You can do map lift term. Let's go subst. Fantastic. I think that takes care of everything. I would just have to do these other substitutions starting from the top. So here is a list of terms. If it's correct first try, I will be very impressed with myself. I remember it being more complicated. Like you need to shift some things, but not everything. That is, I'm probably oversimplified something, and it's going to bite me soon. But so we have a substitution. We don't have all this to do. We just need to subst. We can keep y. We don't need to rename it. And this is the substitution, but it's shifted because it doesn't substitute the y. So shift subst and p, because p prime is not a thing. Yes. Yes. Well, when I hit a lambda, I'm supposed to shift. That's the idea. And I think that's just adding a 0 on top of the thing and lifting everything else. Like all zeros refer to ones and one refers to 0, etc., etc. I think maybe the more complex things are done because you want to have a compact representation of your substitution. And so you have this substitution always start by a sort of you can see the substitution are starting with a bunch of 0, 1, 2, 3, and you want to represent that part of the substitution as a single thing to spare some space and time and other things, maybe gold, money, silver, things. Who am I to judge anyway? There are tiny fly-like things flying around my screen. It's very distracting. I don't know where they came from. Maybe the events. Shoo. I have trouble focusing. It's super distracting. Again, we don't have to do this game. We just do y subs prop of shift subst. Yeah, anyways, if you wanted to represent things not as a list, but as a sort of slightly more complex data structure, then you have some trickery to do to represent the thing. But I think right now it's, oh yeah, it's the same thing again. It's every time the same thing. We're almost going to be over with this. Then we're going to do the smart things. Soonish. Boom. Have more substitutions, I think. No, we don't. We're done with substitutions. Wow. Okay. I think we need to start from the beginning and look at what all this is. What's my substitution here? I need to change my view for unification so that I completely forgot about all this. It's U-term that I need to change, I think. Where is it? Define. Oh no, that's from substitution. So I'm I forgot. So I'm using a unification library, which is cool, but now I have no memories of why or how it works. And unification.unify UV. So there's an instance somewhere for unification, I'm sure. Wow, that is some readable code if I can imagine one. That's all right. Okay, it's not great. It's okay, I can read it. So you have a bunch of things, maybe a list or anything traversable. You take all the elements which are pairs and whose second element is discharge, and then here you just take the first component of each of these because you know the second is discharge. You don't care. Fantastic. Anyway, back to unification. What was this again? Unification.uterm. Where does uterm come from? Oh, maybe unification is something I defined? No, unification is really the library one, yeah? Definitely, yeah. So uterm is something from... That's surprising, actually. Let's just have a look at what this is. I think it's called FD unification. It isn't. Cabal, my cabal. Unification FD. Thank you. So that's a generic thing, but when I do subsumes, I have this to-uterm thing where I take a uterm of a term view, and that's term view that I may need to change. Term view. Do I ever walk back from a term view? Right. Actually, in that case, it's fine. It's how do I call that? Data term. There's var and nvar for a named var. I'll have to remember this. Oops. What is term view? Term is fix of term view, basically. But I don't want to define it this way because it's annoying. Most of the time, what you want is term. So another way I could do this now that I have my own types is to define it this way and define a bunch of pattern synonyms. That would work too. So that I can And so it's basically used for congruence closure and for unification. Yeah, I use it in 2 places. So this is the unification bit. And this is what I need for congruence closure. And I never reconstruct one of these. It will be important for the future. It means I can completely forget about the identifiers when I have binder. That's just yeah. And maybe so one thing of note is that maybe we'll use something a bit more complex later to be able to deal with associative commutative operators. I'd really like to get the associative and commutative theory down, because it's something that we just read out and not think about, and I want it to be about the same in the reasoning. There is, you see AC things, well, you reason them, you reason, yeah, modulo AC, it just makes sense. But it turns out that having AC everywhere is a bit hard. I know how to do AC unification. It's very fun and very inefficient. But like AC congruence closure is something that I haven't quite figured yet. I mean, I've got some ideas, but it's just it's not everything. So why do we do this? 2 terms subst. Ha. I don't remember what I'm doing here. So map unification mball, that does it unify, but I've got this unification.freevar, that insert xv. What am I doing? Oh, I see. Oh, well, that's easy. Okay. You can just replace the map by a list. What am I doing here? Quite easy. Every time I see a for all, I just generate a new unification variable for the rest, because I'm trying to see if that for all, that universal term, will match something. I'm just saying, oh, if I want to instantiate the for all with something, I don't know what yet. So I generate a unification variable and I apply the rest of the term. And when I'm done with the for alls, I get an equals. The rest I just ignore. More things later, really. I get an equals, and I got these 2 things, and I just get to compare the terms together. And now I use unification. If it works, then it unifies. I don't even need the return type. So it's going to be easy. I can replace this by an empty list, which is my substitution. Now I've got this generic substitution thing. And the map is here to do a multi-substitution. But now we don't need this. So we see we don't need the annotation. We don't need the T, which I guess is dangerous. Definitely is wrong. All right, this went like this. Not wrong, like false. Like plain false things. Shoo, shoo. Okay. So of course this is wrong. But anyway, the point is we do v colon subst here, 2 term subst, and I really need a function for this. What I'm going to do, I'm going to go back to substerm. And I'm going to do I'm going to do the simplest possible thing. I'm going to do subs var takes a list of term, an int, and returns a term, and that will be subs var subst and I, and then it's just going to be this. Except that I don't have u anymore. I've got var I. Never mind the duplication, and here I can remove the u. I'm not going to use it anymore. Oops. And that is subst var subst I. Okay, and now we're going back to where we were, and here yeah, that doesn't work anyway. Okay. I don't need this. Never mind. Okay, sorry. So I could have a function for this, like general this function for this, but never mind. That sounds wrong. No, that's correct. That's because it's the one I'm this one I'm matching against. This one I'm matching this, which is a term, against this, which is a pattern, and that's the reason for the asymmetry. Okay. Here we're just going to, for the time being, use the annotation here. I'm just here we just do this. That is true. That's envar. And we add what's constrained. That's a function I wrote like yesterday or last 2 weeks ago or something. I don't know what that is. Oh, that's the underlying constraint. Yeah, okay. And that takes an type, term, and a prop. Right, and yeah, and of course it's var x. Really? Oops. Boom, boom, boom. Well, that was a typo. I'm pretty sure. We just removed x in that story. It's not a member of globals. Oh, wait, sorry. No. In that one, we have x indeed. Yeah, because that's x here. It's the other case where we don't have x. Excellent. But these are all envars anyway, because now I've got a name. That's the reason for envars to begin with. And we can do... Of course, we could suspend these, etc., etc. That's a good idea. If you have an open recursion definition of terms, something you can immediately do is say, oh, I've got these terms with explicit substitution, possibly at every node. You just like push things further as your pattern matching. Very efficient, actually. You can get a lot of leverage out of just this. Substitutions like this, I'm here again. Having explicit substitutions in your terms sounds a lot like lazy evaluation of substitutions, but it isn't. And the reason for that is that explicit substitution, they will merge. If you have an explicit substitution versus an explicit substitution, you are not going to be able to keep them because you have a single one. So when you push one through, they will merge into a single bigger substitution. And that looks completely innocent, but it changes exponential quadratic behaviors into linear behavior because you are not going to push n substitutions one after another, rebuilding things several times. And it makes a huge difference in efficiency in practice. I know because I've tried. I once implemented lazy substitution, and I think it was in Cog, and it was disastrous compared to explicit substitution. Maybe it was not in Cog. I don't remember exactly, but it was really not as good. Whereas if you merge things together, you you guarantee some kind of sharing, but you lose another kind of sharing. Because if you take the same term, which is not mutated, the pushing of substitution being part of your semantics is not actually memoized. You could probably do that. I've never really got around to do something like this. You have the substitution at every node, but it's really all all refs, and whenever you pattern match, you just push things, and you never do this computation again. That's probably doable. It requires quite a bit of effort to do right. That would be very neat though. And so you get your folds and your views and all of these. Like if it was the normal, so the outside semantics of the term is just exactly the fixed point of a functor, the normal functor that you want for terms. But instead of implementing it like this the obvious way, everything is mutable because you're just constantly pushing and merging a substitution, and that would be a tremendously efficient implementation of things. And in very many cases, it's just kind of free to use. It looks like a term, and that's there's a lot of efficiency to gain from this, but it's not that easy to do. There's some care to have. Like if you're explicit substitution, if there's a global one, you can't do this because you might want to backtrack and to test things again. Another substitution, it's subtle, but in certain cases, it's just very efficient. You can have even more efficient things to make merging substitution efficient, having semi-abstract machine sort of things. Anyway, why does induction take a number, a name, an identifier? Sure, I guess. I only need 3 anymore that much, but it's here. By induction on ident. Oh, sorry. It's yeah, it's an identifier in. Ooh. Oh. Oh. Wait. Fascinating. I need a new form of substitutions on preposition that substitutes a term, but that never is affected by a lambda. So it's a very easy substitution. I can just ignore all the lambdas. It's completely unaffected. Let me just, if I manage, close out this window. Oops. Aha. So actually, that is not true. So I'm going to go to subsprop and define a named version of this. Takes an ident, and term, at time, prop and a prop, and quite simply, what is map subs? Yeah, just substitutes into all the subterms. So subs and prop equals prop map subs. So I'm going to see what I'm going to need, and then subst and term of sorry, I need the x and the x and t and xt subst r type xt. Yeah, I thought we might have time to do something else, but I guess the beginning, the introduction was a bit too, not subcell type, subst and prop. So this one is already defined. This one though is not going to be very long. So just going to copy this time because I don't need this. Violent term. Okay, now I need a subst end term. And again, this one is going to be, this one is going to do the job though, not the job, the work. xt, envar y, x equals y, then it will be t, otherwise it's going to be u, and for the rest, subst, that is extend t. It's probably just pure hypochondria, but I feel like these insects are eating me. The n is, oops, the n qualifies as subst. It's subst n, like subst named, but I'm a bit, okay. Now I can do, not that one. Interesting. My point was that is n, and that is n, and that is because we're actually substituting something that is named. E. If I do the scope thing, these substitutions will become interesting again. Maybe. At least it's slightly less trivial. And that is an envar, of course. My brain is making this up. I think there are only 2 bugs. They're just around me. I get to know what. Okay. Let's have a look. That is with. Check the time. Yes, probably. So that's just a substitute. There's nothing special here. Oh. Underscore. That's what you get for not actually copy pasting things. The comp arrow. This is most definitely, so I don't need this, I think. I haven't done like half the things. We're not going to finish. We're definitely not going to do more than this today. T. I'm not sure I'm actually using this anymore, but who cares? We're actually pretty close to having everything. Aha! Now that is very interesting. I said close. I mean, there's few places to change. However, might not be trivial because I need an environment that encompasses both De Bruyne's and named things. So right now I can already do the name one. And here it's complaining because this... Oh no, it's starting again. Okay, it stops. How did I do that? That doesn't look good. I have to figure out some things. Can I just unplug it and plug it again and see if it still does that? Maybe I just opened it for no reason earlier. No, it still works like this. What is happening honestly there? Okay, so that's enter. This is going to be hard. Let me quickly open it again and see if I see something. I mean, then this time I... I don't have enough computer problems, I guess. So I need to change my hard drive tomorrow. Or something. That's fantastic. And as soon as I remove the keycap, the problem disappears. It makes no sense to me. Hope it doesn't persist because I'm very fond of these keyboard. I have some replacement keycaps though. I can acquire some more if I want. Hello. Can you start? Okay, that is worse. Yeah, I looked in the cap. There doesn't appear to be anything in the cap. But the keyboard is not working anymore. Wow, that is interesting. It's plugged in. It says it is plugged to power. If I lose this keyboard, it's going to be a big problem. It's turning on. Okay. I have no idea how scared I am. I really don't want this keyboard to break. So where were we? I don't know about the warranty, honestly. I'm sure I could get it repaired. It's not the point. It's I don't really have a short-term solution. Right, that's more interesting actually. So now we want to define the function that interprets concrete syntax into abstract syntax. So back to the beginning. So we're going to internalize, it takes a concrete term to a term. Got a dot. Ooh. Well, that is going to be gross. Oh, there's some. There's we need a mapping from. That also does. So interning will have to do binder resolution. Right now we're going to do something very, very simple. We're going to take a map. Do we have? We had a map from items, yeah. Map from ident to what now? Oh yeah, that is so unpleasant. That's not too hard. It's just silly. To int, into terms, subst. So if I see a concrete var x, I do what do I do? For the time being, I'm just going to do oh, it's starting again. Of course it is. Well, except not every time. This is wow. There's going to be a problem. Wow, it just decided to press it on its own. I'm just wondering though, is that... Could that be a USB problem? Well, this is bound to have been the most interesting stream I ever did. And never had to live debug keyboard issues. That is. And this is going on YouTube. Hello, YouTube. Wow. Prime content. I don't know. I'll have to figure this out. So here I just take the substitution. Still going a bit randomly. My God. Yes. Subs.map x. Damn. I was not fast enough. I forgot an N here. Okay. So we have variables, and then we have nat sucks and app. No. Okay, this is not going to work. Let's try to unplug this again. Use it made a horrible noise. I should open the Alt key as well. It's the neighboring key to see if I see something. I can actually unscrew the entire thing, but I'm not going to do it today. It's not clean, but it's not particularly dirty either. And I've got another one somewhere. If I need to. This one is pretty much out of air. Maybe I'll take the other one. I haven't even opened it. It's sitting on this side of things for a while. Okay, so that's a DIY stream now. We've had to spend like half the time on software and half the time on this. Oh, it's not the right time to put things in the bin. So. Okay. Now I have a small straw that I can use, and I'm gonna be able to. No, it's stuck. Do I need to remove this altogether? Yeah, definitely. That is much more serious cleaning, though. There's a hair here. Weird. It's dry, but not too much. I think there's water on the keyboard. Pretty sure there's water in the keyboard. That might explain the problem. What is this? It's getting ice cold. Yeah, probably had water in the keyboard at some point. Have a vague memory of tea spilling earlier today, which is probably my problem. Which is probably going to be fixed on its own tomorrow morning. But let's try to finish this a bit at least, to get somewhere. Oh, there. Shoot. Hey. Well, I guess I'm going to leave you in here. Okay. How do I know there's water in it? Because I got some in my face. It definitely didn't feel like air. It was water with a high level of certainty. Okay. Turn on. Okay. It didn't get better. Oh, it stopped for some reason. Let's try a bit more. But it is likely that I need to just unplug this and Drain rice. Maybe. So I can't do much without my spacebar, and I don't think I have a spare one on this keyboard, but I lost the mapping. That I just don't know where it is right now, but it's not like, oh, sorry. That is worse. Okay. Yeah, show me this. No, that's here we are. No, there's no other spacebar, and right now it has decided that it wants to stop working. I hope that my clumsiness earlier didn't cost me a keyboard. I think I got clumsy and just poured some tea on it. But right now I think that the stream will unfortunately need to stop because this doesn't look very workable. I can that's my fault. Even though I don't know what I can do without a spacebar. I've got things mapped to it too. They'll be hard to avoid. So for the rest, I need. I don't care about the substitution. So concrete net maps to net. This is really hard. I'm pretty sure there's water in this. And that's what's stopping it from working. I can unscrew it after that and let it dry. Spam and eggs. Hey David. Hey David. So I'm probably going to stop very soon because my keyboard is broken. Especially in my spacebar, there seems to be water in it, preventing the switch from working. Right now, I'm inputting space with the mouse, but that can't last for very long. Yeah, I'm going to just open the keyboard and clean it dry, but I probably can't do this on stream. Like in making the binding. Well, the thing is, even if I unscrew it on stream, if you want to see it, I'm going to stop. I mean, I won't be able to work on it. Well, let's try. Let's try quickly, see how it looks like. So I'm going to unscrew this. I can stop the screen with the stream with just the mouse, so that's fine. I'm not stuck. I'm going to unplug this. Okay, so now I've got this part. That's the part that has some water in it, and I'm going to unscrew it, which I think I will remove the stand from it, which is well screwed. I may need to take up a tool for that. Oh, I didn't expect that. Oh yeah, fine. Theory started work. Well, you've got to do what you've got to do. I've got 7 screws. Do you want to see this? Let's okay, let's make it educational. I'm going to add a new scene. How do I do this? Well, never mind. We'll just see it in the small corner. Yeah, no, I mean the previous keyboard is broken. So here is my stuff. You can see the keyboard here. I'm going to unscrew this. You can see my very precious tea on screen. And that's amazing. Let's oh yeah, this is the right half of my keyboard. It's a split keyboard, and that's the screwdriver it comes with. So we're going to open this. I've got many screws, so I need to figure out which one is best for this. This one looks quite perfect, so probably this one. Oh, this one is not good. This, okay. This is the thing. I think I poured tea inside the keyboard earlier today. I'm not sure. So look at what I'm doing for YouTube, eh? Live unscrewing. I'm going to remove this because I'm going to use this space for my screws. Ooh. Okay. Okay. At any rate, I think I will not be able to finish the task for today. It's not very interesting, so I'm probably going to finish it off screen so that we can progress next time. Next time we'll probably feature... Ooh, that is bad. Thank you. Feature us making propositions into terms so that we can abstract over prepositions and predicates and all that. And after that we can do the quotient types. I think that's a pretty good plan. Okay, so this is my first time opening this. It opens very nicely and it is wet. It is definitely quite wet and a bit dirty. I don't think you can see the dirtiness. There's hair everywhere. I haven't opened it ever, and I've had it for about a year. That's interesting. It took me about a year to 2 years. I've only recently been able to be quite efficient at it. I'm going to remove a couple of keys. It'll be a bit easier. They just slide. Yeah, there's definitely water in this. There's water in the electronics probably, and that is pretty bad. I can't really reach it, and I don't really want to unplug it more, to unscrew it more, sorry. Oh, it is super wet. I've got ice on my shirt now. Also, good physics lesson. When you decompress something, it gets very, very cold. And so the air, when I press for a while, exits very cold, and the water that is projected is actually ice, which I've never seen before because I never blew dry air on water. Sorry, I got interrupted. Yes, actually, that's a good point. You can just do that. You just do bring a can of dry air like this and blow on water and see it become ice. So that's all dried up. It looks dried up now. Let me test quickly if I got my spacebar back. Nope. So it's not quite dried yet. I hope the electronic is not damaged. So I think I'm going to let it dry all night. Yeah. I can't see any water anymore, and I got a lot out, but it could be somewhere else, you know. I think I will have to stop now. Did it just flash? Interesting. It's not working very well. That is meta. Yeah, that works. It's really just the spacebar. Well, maybe it is. It just works randomly. Either it doesn't work or it just constantly presses. Maybe I could remove the switch. Key switch documentation. Yeah. Good night, James. I'm going to. No, I don't think there's a mosquito. There's tiny insects flying about that have been distracting me all night, and because when you see those, I don't know, my brain was like, I was itching all over, but like they were eating me, but they probably weren't. These are historical data sheets. It's not what I make. Look in Google. Yes. Key sweep sweeping with model 01. Okay, so how do I remove switches? Opening up the switches and replacing parts of them will void your warranty. Okay. Apparently it's hard. Okay. So it's still stuck. No. Oops. What from or for? I didn't check that. Should really unplug it before. I've seen the illuminating is no good. Yeah, well, that's going to be it for tonight. This is not solving anything. I'm going to leave the screws like this. I'm going to leave these to dry upside down for the rest of the night. And I'll fix it tomorrow morning. Hopefully it's going to be fixed. I will be very, very mad if I can't fix this keyboard. Oops. Still have the other one half, but this one has the space bar, among other things. Hello again. Yeah, so I'm not sure all of this content is going to go to YouTube. So yeah, it's a bit of a bummer. I haven't finished all I wanted. Oh, my enter key is in the other one. Shoot. Oh, I don't need to do enter. I know CC. Okay. So everything is told. Yeah, enter is on this key as well. It's over here. And I've got a secondary enter on the spacebar, but as you might have noticed, it's not really a solution. I really have no idea how this sort of happened like this. Well, I probably poured some water on it, but it just weirdly happened over time. This is a pity. And if I want a replacement, I'm going to have to wait for a while because they don't have any right now. Hopefully it fixes itself after drying for a while. I'm very sad. Yeah, maybe. So I discovered it was wet because I suspected it was dirty, so I poured dry air on it and then suddenly got water all over my face, which is not what you expect. And then I sort of could confirm it. But I hope it didn't short something that is too fragile and damaged it. But it's only the spacebar key, so the switch could be damaged, and that would be a pain. I mean, it could be replaced, but that's tricky. And you need to solder, I think. Fun. Yeah. So anyway, that was an interesting stream, I suppose. I'm a bit scared for my keyboard. So the program is what I was saying. Next week, I'm going to play some video games, come and chat. Just a place for chatting about things that's a bit more free form than me live coding. And 2 weeks from now, I'm going to resume on this. I'm going to try to finish what I was doing today. There's not much more interesting things to do, and and until yeah, sorry, not until then, but and then I'm going to address this idea of making proposition not a separate syntactic category, but termed the particular type, which is something we're going to need soon enough, because it just provides us so much abstraction. And after that, we're going to try and address quotient types, I guess, and we'll have a lot of the basic bricks to build this proof assistant and start actually playing with maths. Maybe we're not there yet, I guess, but we're getting closer. So that's the program. I'm going to cut stream on this very disappointing keyboard repair session, and yeah, so see you everybody soon. Thank you very much for joining, and until next time, don't forget to stay curious.